Hello guys. So in this video, we're going to be trying to determine that if hydrozoic acid or cyanic acid has a more acidic proton, or simply said is more acidic. So in this case, we're going to look at three factors. First one is going to be size. Second one is going to be electronegativity, and the last one is going to be resonance. Before we're gonna solve anything, we are going to first make the Lewis dot structures of both compounds. So hydrozoic acid is HN3 and cyanic acid is HOCN. Both have 16 valence electrons and both have very similar linear structures. So HN3 is HN double bond N double bond N. Two lone pairs over here, one lone pair over here. For HOCN is going to be similar H, O, C, and triple bond N, like that. So that is our Lewis dot structures. So next we're going to find out their conjugate bases. For HN3, it's going to be N3 minus, which is N minus, double bond N, double bond N. And for HOCN is going to be OCN minus, also O minus Cn, triple bond N. So the first factor we're going to look into is size. So in this case, both structures are very similar. Both structures have very similar size, and the difference is negligible, and we can actually ignore the difference in size. So in this regard, it is going to be not applicable for us. For electronegativity, the two atoms that matter in N3 minus is going to be N, and in OCN minus is going to be O. N has an electronegativity of 3. O has an electronegativity of 3.5. This makes O a better candidate to hold the negative charge and making it more stable in that form. Over here, we don't have any other option, so the negative charge is going to go to either of the nitrogen atoms. So for the last factor we are going to talk about is resonance. So we know that both of them have resonance because both of them have pi bonds. In the case of OCN, there's a triple bond. In the case of N3 minus, it's a single bond. So N minus double N, the negative charge is going to go over to the other side. It's going to be N double bond N minus N negative. And then it is also going to go to the other side, which makes it N minus N double bond N. So we got three resonance structures, and the negative charge is distributed over three different atoms. In the case of OCN minus, we have O negative, C triple bond N, and the only other way is this goes over here. Yeah, this bond goes over here, and it's going to be O double bond Cn double bond N minus. So, when we're looking at resonance, we can tell that N3 minus, the conjugate base, is more stable because the negative charge is spread over a larger area, is spread over three different atoms, and it has higher resonance. While in the case of OCN minus, it can only go on either oxygen or nitrogen. And in that case too, oxygen is more electronegative, so it is more favorable for the negative charge to be on O and not even on N. In N3 minus, or the conjugate base of hydrozoic acid. It is the same electronegativity all across the molecule, making it easier for the the negative charge to like move across the molecule. So even though the electronegativity of oxygen is higher, making it more stable for a negative charge, the resonance in this case matters a bit more, making N3 minus more stable as a conjugate base due to higher resonance and negative charge spread over more atoms. OCN minus, even though it's pretty stable, is less stable due to lower resonance and less space for the negative charge to move. So, what can we get from this information? So, if N3 minus is a more stable conjugate base, it means that the acid of the conjugate base is going to be more acidic, making hydrozoic acid more acidic and cyanic acid as less acidic in this case. So, just for a short recap, we used size, electronegativity, and resonance to figure this out. The size was relatively the same across both molecules. Electronegativity, when talking about electronegativity, oxygen has a higher electronegativity, making it more stable and more favorable to have to have a negative charge on it as compared to nitrogen. In resonance, we can see there's a difference. There's higher resonance, three different structures for N3 minus, in which the negative charge can move around pretty freely. In OCN minus, it can either go on oxygen or nitrogen. In that case, too, it's more preferable to stay on the oxygen due to its higher electronegativity than nitrogen. So, what we figured out is HN3 or a hydroxylic acid is more acidic or has a more acidic proton than HOCN or cyanic acid. Thank you.